Assalamu alaikum warahmatullahi wabarakatuh. So in today's presentation, we are talking about building AI models using a numerical dataset from IEEE data board. So the main objective of this assignment is to get some numerical dataset from IEEE data board so that we can build and evaluate AI models. So let me first go to my presentation. And so this presentation will be based on this AI model, linear regression. First of all, I'm Mohammed Abdullahi Hamdi, and this is my registration number. So the module is called Artificial Intelligence and Intelligent Systems. So we first define what is a linear regression. So linear regression is an algorithm that provides a relationship between an independent variable and dependent variable so that it predicts the outcome of future events. It's a statistical method used in data science and machine learning for predictive analysis. So you can also define a linear regression is a statistical algorithm that helps us understand the relationship between two variables. So what are the two variables that we are talking about? So the first variable is an independent variable. So an independent variable is the input or the predicated variable, which we believe it has an impact on the dependent variable. So the next variable we are talking about is the dependent variable. So what's a dependent variable? A dependent variable is the output or the response variable that we want to predict or explain. So what kind of goal do we have? What is the goal? So the goal of linear regression is to find the best fitting straight line that represents the relationship between these two variables, the independent variable and dependent variable. So the algorithm assumes that there is a linear relationship between the independent variable and dependent variable, and then it will determine the slope and the intercept of the line, and then it minimizes the difference between the predicated value and the actual values of the dependent variable. So then the line can be used to make predictions about the dependent variable for new values of the independent variable. So if this model, called linear regression model, is widely used in data science and machine learning for predictive analysis. So it allows you to understand how changes in the independent variable influence the independent variable and make predictions based on this understanding. So it's a value tool for tasks such as forecasting future trends, estimating the impact variables, and identifying patterns and relationships in the data. So then we come to the next slide. Why linear regression? Why do we need to use a linear regression? So linear regression model has become a proven way to scientifically and reliably predictable because linear regression is a long-established statistical procedure. The properties of linear regression model are well understood and can be trained very quickly. So linear regression models have gained a popularity as trusted and effective method for making predictions in various fields. So these models offer a scientific approach to understand and forecast the relationship between variables. So you can establish a mathematical equation that represents the relationship between an independent variable, or also you can call it the input and the dependent variable, and that one you can also call it by the output variable. So what kind of advantage can we get using a linear regression? So one of the advantages that linear regression is to well-established statistical properties. So this methodology and assumptions behind linear regression have been extensively studied and understood for many years. This means that you can have a solid foundation of the prediction. So also a linear regression model offers available for various domains. So now we talk about the dependent variable and independent variable. So what's independent variable? Independent variable, also known as the input or the predicated variable, is the variable that's used to predict or explain the variation in the or explain the variation in the independent variable. So dependent variables, you can call it the output variable, is also known as the target variable or the response variable. This is the variable that you want to predict or explain based on the independent variable. So the independent variable is also a predicate or explanatory variable that remains unchanged due to the change in other variables. So in a predictive analysis, the independent variable is the one that we believe it has the influence on the outcome that we are trying to understand. So while the other hand, the dependent variable is the one that we want to predict or explain based on the independent variable. It's like the effect of or the outcome that you're interested in understanding. So you may need to know how the study time or the independent variable influence the exam scores, the dependent variable. By analyzing the relationship between these two variables, you can gain the insights how changes the dependent variable. Let's go to the fifth slide. This fifth slide, we're going to talk about some key benefits of linear regression. So the first key benefit is easy to implement. Linear regression is easy to implement. Why do we say that? Because the aspect of linear regression refers to the simplicity and efficiency with which the model can be set up and used, unlike more complex models. Linear regression does not require a lot of additional tasks or technical expertise before the model can be launched. It doesn't demand extensive processing of data or the structure feature engineering. So the process of implementing linear regression is straightforward and does not involve significant amount of extra work. So with this easy implementation of linear regression, it means that it can be quickly applied to a data set without complex processing or so a feature engineering. So the next one is scalability. Scalability in linear regression is not computationally heavily and therefore it fits well in case where scaling is essential. For example, the model can scale well regarding to the increased data volume. So let me explain the concept of scalability in linear regression. So the scalability of linear is the ability to handle larger sets and increased computational demand without compromising it is in performance. So linear regression is known as for being computationally efficient, meaning it doesn't require significant computational resources or processing power to analyze and make predictions on data. So some practical terms, this means that the linear regression can handle larger volumes of data, including what is commonly referred to as big data. As the amount of data increases, linear regression is able to scale effectively without experiencing a significant slowdown in processing time or compromising the accuracy of its predictions. So another key benefit of linear regression is the optimal for online settings. The ease of computation of these algorithms allows them to be used in an online setting of the model that can be trained and retrained with each new example of generating predictions in real time. So this optimal online setting, it refers to the stability of linear regression algorithms for applications that require a real-time prediction. and continuously learn from the incoming data. So in an online settings, linear regression model can be trained and retrained within each new example of or data point that becomes available. So this means that the model can adopt and update these predictions in real time as new data received. So the ability to train and update the model quickly allows for timely and responsive predictions, making it well suited for applications that require immediate decision making or continuous monitoring. So let's take an example based on optimal for online settings. So in an online advertisements, linear regression can be used to predict a user behavior and optimize some ad placements or some advertisement placements in real time as new data about a user interactions and preferences collected. The model can be trained to adjust its predictions and improve the targeting of the advertisement. Similarly, in the financial markets, linear regression can be used to analyze real-time data and make predictions about stock prices by the market. So, to be able to train and generate predictions in real time, linear regression provides a practical solution for applications where timely and up-to-date predictions are essential. So now we talk about four types of linear regression. The first one is simple linear regression. Simple linear regression reveals the correlation between a dependent variable, the input, and independent variable, the output. A multiple linear regression establishes the relationship between independent variable that has two or more independent variables and the one corresponding dependent variable. So simple linear regression is a statistical technique used to understand and quantify the relationship between two or more variables, a dependent variable and independent variable. So it helps us to determine how genes in a dependent variable impact the independent variable. So the dependent variable is the one that we are trying to explain, while the independent variable is the variable that we believe it influences or affects the dependent variable. So multiple linear regression is an extension of simple linear regression. It allows you to examine the relationship between a dependent variable and multiple independent variables. So what is the goal? The goal of multiple linear regression is to determine how these independent variables collectively affect the dependent variable and to quantify the individual contribution. Then we come to the logistic regression. This logistic regression, also referred to as the logical model, the logic model, it's applicable in case where there is one dependent variable and more independent variables. So the third one is ordinal regression. Ordinal regression involves one dependent legitimate variable and one independent variable, which can either be ordinal or nominal. And the last one is multinomial logic regression. This one is performed when independent variable is nominal with more than two levels. So now we come to the linear regression model, the graph. So in the x-axis is the independent variable, while the y-axis is the output or the dependent variable. So this line, you can also call it the line of regression. So those dots, they are the data points, so that we will see them, those one, as an example or a practical in our code. So what is the rule of this one is the rule that we are going to use so that we can implement and code so that it generates this graphic. So let me explain this rule. So this y represents the dependent variable, which is the variable that want to predict or explain. Then this x represents the independent variable, also known as the predicate variable, which we are going to use to predict or explain the variation in the independent variable. The AO or A0 is the y-intercept or the consistent term, which represents the value of y when x is 0. So A1, this A1 is the coefficient or slope of the independent variable. So it represents the change in the independent variable. It also associates with 1 unit change in the independent variable. And this error, it's the error term or residual, which represents the unexplained variation in the independent variable. So here are the references. Now we go to our code. So this is our code. So let me explain the code first, line by line, or a group of lines together. So here, we first start the code by importing the necessary files. I mean the necessary libraries like Benda, multiple liter plots, so that can help us for plotting, then skill linear model, then import a linear regression, then those metrics so that we can use or evaluate our model. So then the next line, this line will read the data from the CSV file named online learning data. Then the third line will be, and this one will, this line will be, well, we are going to prepare the input and the target variable. So the month in this data frame is extracted and converted to ordinal. It's called to ordinal and values using the apply method and lambda function. So then we are going to create and train our linear regression model. So, and then we are going to make some prediction for the entire data set. So I've jumped for this line. This line we are going to use with counter that we want to predict every time, so that you can also see we will see the graph here after we have used the line here. And so then the last line, the code plots the actual data into blue points using the scatter function, and plots the linear regression as red line using the plot function. So let me run the code once so that we see the code and our linear regression model in action. So as you can see, we got the output here. So this here we have the year. So let me first explain once what kind of data set that we are using, and that we are also going to implement or it's producing this thing here. So this data set we are using is called an online learning data. It's a CSV file that I have downloaded from the individual website IEEE data ports. So I have got that one, and I'm going to implement it to our AI model. So it's basically online behavior that was conducted before and after the COVID-19, and there are 20 countries that have taken as a sample, and then we will see each and every one. So we will take a sample now. If we change to France, so the graph will change. So as you can see, the graph has changed. So those are the months of the year, start from 2004 up to 2021, and then here are the year. So I use this here because if I want to use 2004, 2005, 2006, 8, 9, something like that, the graph will be messy and no one is going to understand it. So that's why I've used this to ordinal. So I cannot use it to here. And here are the data points of the months of each year. So and here is the date that I have in the CSV file from 0 up to 100. So I think that's all for my presentation. Thank you.